Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And the topic that we are going to start is integration, and we shall be doing the introduction of integration today. So, what is integration? Integration is the reversal of differentiation. It's the reverse process of differentiation, meaning if in differentiation the equation y in terms of x is given to us, then we differentiate it to get the first derivative dy by dx or f prime x. And then further, we differentiate it again to get the second derivative d2y over dx square or f double prime x. We know the first derivative that represents the gradient, and the second derivative here, it represents the nature of the stationary point. But in integration, if the second derivative is given to us and they have asked us to get the to get the gradient of the curve, then I shall be integrating the second derivative to get the gradient of the curve. I shall be integrating the second derivative here to get the gradient of the curve, and in return the gradient of the curve, the first derivative dy by dx or f prime x, this should get integrated to get the equation of the curve. So this is basically the difference between differentiation and integration. Integration, it's also called the antiderivative. Antiderivative, or the reverse process of differentiation, this is all that we should be calling for integration here. And also the major differences between the two is that in differentiation, we eliminate the constant term in the equation, whereas in integration, we always have to add a constant. Again, the opposite over here. And also in differentiation, we subtract 1 from the index of the variable, but in integration, we have to add 1 to the index, and then I should be adding a constant here. So the basic formula for integration is that if our dy by dx is equal to x to the power n, then if I need to integrate it, then this is the symbol of integration. This is a symbol of integration of long-tailed s. This is integration. So if I need to integrate dy by dx, integrating both the sides, I should say it's integral of dy by dx, which should be equal to integral of x to the power n. Or I can say it's the integral of dy, which shall be equal to integral of x to the power n dx. I'm integrating x with respect to x here. So integral of dy shall be equal to a y, and then integral of x to the power n, adding 1 to the power n, I should say it's n plus 1, and then this n plus, I should be dividing the entire equation, entire term, by n plus 1, and then I have to add a constant plus c over here. So this is how basically integration gets done, provided that our power should not be equal to a -1, because -1 plus 1 shall give us a 0 here, and -1 plus 1, this is a 0, and any number divided by 0 is undefined. We do not want our equation to be undefined. So this is the case where we say that its integration is possible for these cases, so that our n is not equal to -1. So let's start working on some questions. So find y given dy by dx in each case. I have given 3 questions here. Part A, it says, so part A, our dy by dx is given as a 10x plus 8x to the power 7. So dy by dx, I can take dx on the other side, 10x plus 8x to the power 7, and this is dx, and I need to integrate it to get my y equation, and the question says find y in each case. So I shall be integrating it here. Integral of dy is just a y, and this then shall be equal to 10x, the power is a 1, I should be adding a 1 here, and I should be dividing it also by a 1 plus 1, which is a 2. And then to the second term, it's 8x to the power 7, again adding a 1 to 7, and then dividing it by 7 plus 1. and then I should be adding this constant c here. So this means my y then becomes a 10 divided by 2x the whole square plus 8 divided by 8x to the power 8 and then plus c. So I can say that my y is equals to a 5x square plus 8 and 8 simplified gives me a 1x to the power 8 and a plus c. So this is how I shall be getting my equation of the curve y in terms of x. Now the question arises how to find C. So if in the same question they would have said that there is a point on the curve, I'm just giving an example that if in the question they would have said that there is a point on the curve A with coordinates, let's say it's a 2 and a 3, then find the equation. So find the equation of the curve. So we already have the equation of the curve. The only thing is that the constant is not known to us. So to get the constant, I shall be substituting this point A with coordinates 2 and 3 in the equation, which is going to be 3. My y is a 3, and then it's 5 times 2 the whole square plus 2 to the power 8, and then it's a plus c. Or I can say it's 3, which is equals to 2 square 4, and 4 times 5 is a 20, plus this then shall be a 256 and a plus c, or I can say it's a 3 minus 20 minus 256, which then shall be equal to a c, and this c then is going to be a minus 273. Meaning from here I can very easily say that my curve equation is going to be y, which is equals to 5x square plus x to the power 8 and a negative 273, and this is then going to be the equation of the curve. Part B says it's the dy by dx, which is equal to x times x to the power 4 and a negative 6. So here I can say it's dy. Simplifying or expanding the terms, I should say x into x4, that gives me x to the power 5 and a minus 6x, and this is dx here. I need to integrate it, so I should be having this integral sign. Integral of dy is just a y, x to the power 5 adding a 1, that gives me 5 plus 1, which is a 6, so I will be dividing this by 6, and here it's 6x to the power. The power for x here is a 1. Add a 1 to the power, that becomes a 2. I should divide it by a 2 and then add the constant here. So simplifying it further, I should say it's 1 by 6 x to the power 6 minus 3x square and then plus c, and this then is going to be the equation of the curve. Part C says 2x minus 3 the whole square. So dy by dx is given as 2x minus 3 the whole square. Again, I can say it's dy, which is equals to 2x minus 3 the whole square and a dx. I need to integrate it to get my y. So the sign of integral here, and then it should be y, which is equals to, now to integrate this 2x minus 3 the whole square, I should be applying the formula for a minus b the whole square, which is a square minus 2ab and then plus b square. So I can say that this here is 2x the whole square minus 2 times 2x and a 3, and then it should be 3 the whole square, and this is what we need to integrate. So I can say it's y, which should be equal to the integral of 4x square minus a 12x and then plus 9 dx. So integrating this y, this becomes 4x to the power 2 plus 1, that gives me a 3. So I should divide it by a 3, minus 12x to the power 1 plus 1, that gives me a 2. So I should divide this by 2. And then to the constant here. So this is what we said in the beginning. The difference between differentiation and integration is that in differentiation we eliminate the constant, and in integration we have to add a constant. So this means to add this constant to this 9, to this constant that I already have, I should not be eliminating it, but in fact I should say that this is 9 to the power x. And the reason to get this is, if I say that it is a constant, it means that there is an x and it has a power, which is 0 here. So to this 0, if I add a 1, it will be x to the power 1, and dividing it by 1, obviously it's just going to be a 9x. And then in the end, I should be adding a constant. So this means our equation y is going to be a 4 by 3 x to the power cube minus 6 x to the power square plus 9x, and then it's a plus c, and this is then going to be the equation of the curve. So now if the question says find the integral of 2x plus 5x to the power cube divided by x, find the integral of 2x plus 5x to the power cube divided by x dx, then simply the first thing that we shall be doing here is to have separate terms with respect to x. So that means it should be 2x divided by x and then 5x cubed divided by x again, and then dx. So integrating all the terms with respect to x, I should be having a 2 here, and then here it should be a 5x squared, x cubed divided by x, give me an x squared, and then I should be having dx. So in the next step, as I shall be doing the integration, so I won't be writing the integral sign. I'll just say it's going to be a 2x. So this constant, it won't get eliminated, but an x will be introduced with the constant. It's going to be a 2x. And then here, I should say it's 5x to the power 2. That means add a 1 to the power. 2 plus 1 gives me a 3. So divide this by 3 and add a constant here. So the integral in this case is going to be 2x plus 5 by 3, x to the power cube, and then plus c. So this is then going to be the answer to this equation. So let's integrate with the radical sign. So this says it has to be the integral of square root of x minus square root of x plus 5 the whole square and dx. So with respect to this square, let's first apply the quadratic identity for a plus b the whole square, which is equal to a square plus 2ab plus b square. So applying that, I should say that this is going to be the integral of x to the power 1 by 2 minus, now here it should be under root x to the power square, and then plus 2 times square root of x times 5, and then it should be plus 5 the whole square. And further, I should say that this is then going to be x to the power half minus, now here it's square root of x the whole square, the square roots, the two square roots here, they get eliminated, the two square roots here, they get eliminated, and I shall just be having here and x, and then a positive 10x, and then a 25 dx, meaning I should have a positive 10 square root of x plus a 25. So meaning I should be having here x to the power 1 by 2 minus x minus 10 x to the power 1 by 2, and then a minus 25 dx. So the two terms here, x to the power 1 by 2 and minus 10x to the power 1 by 2, I can solve the two of them, and I can say that this is a minus 9x to the power 1 by 2, and then a negative x and a negative 25 dx. So solving further, as I will be starting my integration, I will not be writing the integral sign. In fact, I'll say it's minus 9 x to the power 1 by 2 plus 1 1 by 2 plus 1, that gives me a 3 by 2. So I should divide by a 3 by 2 minus, now x, the integral of x here. So this is a positive 1 plus 1, and then I should divide it by 2 again. And then with 25, I should be having my x to the constant. I should be adding the x and then add the constant, see here. So further I can say it's minus 9 into 2 divided by 3 x to the power 3 by 2, and then minus 1 by 2 x square minus 25x and a plus c, or further I can say that this is going to be a negative 6x to the power 3 by 2 minus 1 by 2 the whole square x to the power square minus 25x and a plus c. So this is how then this integral shall be found here. So the second question here says a curve is such that dy by dx equals 5 divided by square root of x minus 10 and then square root of x cube, and the point 1 comma negative 6 lies on the curve. So we need to find the equation of the curve. We need to find the equation of the curve. So as said earlier, our dy by dx is given. It's dy by dx, which is equals to 5 divided by square root of x and minus 10 square root of x cube. And there is a point on the curve. Let's call this point A, and this point is a positive 1 and a negative 6, and this point lies on the curve. So this is going to be helpful in finding the equation of the curve. So the first thing is that I can see that here it's the dy, which is equals to 5 x to the power. I'm taking this x to the power 1 by 2 from the denominator to the numerator so that the sign changes and it becomes a negative 1 by 2. And then here, solving for the radical, we know that the radical means that it has the power, which is a 1 by 2 here. So this x cubed to the power 1 by 2, power to power, they get multiplied, and I can say it's dy, which is equals to 5x to the power negative 1 by 2 minus 10x to the power 3 times 1 by 2. That will give me a 3 by 2, and then it's dx. So to get the equation of the curve, I should know that what it means is to get y in terms of x. So to get this y in terms of x, I have my dy, and with respect to the differential x equation, so I should be integrating both the sides. If I integrate both the sides, then with the integral of both the sides, the integral of dy becomes a y. And here I should say it's 5x to the power negative 1 by 2, add a 1 to the power, divided by negative 1 by 2 plus 1, and then to negative 10x to the power 3 by 2, add a 1, and then again divide the whole term by the power with 1 added to it, and then add a constant here. So with that, I can see that my equation here becomes 5x to the power negative 1 by 2 plus 1. That gives me a positive 1 by 2, and divided by negative 1 by 2 plus 1, which is a 1 by 2 again. And then here I should be having minus 10x to the power 3 by 2 plus 1, that is a 5 by 2. In the denominator also, I should be having a 5 divided by 2, and then I should be having the constant here. So simplifying the denominator, I know that if it is divided by, I'm just writing this function here. If I have A divided by B divided by C, then what it means is that A is getting divided by B divided by C, reciprocating the function, it's A times C divided by B, or I can say it is AC divided by B here. So I'm going to apply the same thing here, so that if it says it's 5 divided by 1 by 2, then simply I should say it's a 5 times 2 divided by 1. I don't need to write that 1 in the denominator. So it's 5 times 2 x to the power 1 by 2. And then here it should be a negative 10 times 2 divided by 5 x to the power 5 by 2 and the constant that we have added to the equation. So solving it further, it's y which is equals to 10 x to the power 1 by 2. This gets simplified. It's 5 ones are 5 twos are, and then it's a negative 4x to the power 5 by 2 and a plus c. So this is then going to be the equation of the curve here. So the problem is this c. I should be finding out the c value also. So to find the c value, I should be taking help of the point which has been given to us, and this point is 1 comma negative 6. I know that on this curve there is a point which is 1 comma negative 6. That means I can substitute this point in the curve equation that I have just found to get the value of c. Meaning here I should say it's a negative 6, our y coordinate, and then it's 10, 1 to the power 1 by 2, minus 4, and again 1 to the power 5 by 2, which will be a 1, and then plus c. So negative 6 equals 10 minus 4 and a plus c, or I can say it's a negative 6 which equals 6 plus c, or negative 6 equals a c, or I can see that here the c value comes out to be a negative 12. With this negative 12, I can very easily get my curve equation, and I can say that it is y which is equals to 10 square root of x minus 4 x square into square root of x and a plus c, which for which I already know the value as a negative 12. So why have I taken x square into x to the power into under root x? I have here x to the power 5 by 2. So with this 5 by 2, I can simply say that this is then going to be, if I say that this is a 1 by 2, then I should add a 1, so that I should add a square. To this 1 by 2, I should add a square, so that I shall be getting here a 5 by 2, because 1 by 2 plus 2, that gives me a 5 by 2, or I can say that this x to the power 5 by 2 in two forms can be written as x square into x to the power 1 by 2, or x square and square root of x. So this is then going to be the curve equation that we shall be having for this gradient value here, and the point that is given to us as 1 comma negative 6. The third question says that the curve is such that d2y over dx squared, the second derivative, equals 6x. So let's copy down the data. It says it's the second derivative d2y over dx squared, and this is equals to 6x. The curve has a maximum point. It has a maximum point when x equals minus 1. So if it is the maximum point, then we know that our first derivative dy by dx needs to be a 0. Maximum point, minimum point, stationary point, they all mean the same, where the gradient equals a 0. And this is happening when our x equals minus 1. So I have this condition also, that with respect to the maximum point, our first derivative equals a 0. And this is when x equals a negative 1. And there is a point 3 negative 2. There is a point 3 negative 2 which lies on the curve. So let's write this point A as 3 and a negative 2. This lies on the curve. And we are supposed to get the equation of the curve here. So obviously, to get the equation of the curve, that means I have to have my y in terms of x, and the information starts from the second derivative. So we know integration being the reverse process of differentiation, I should be integrating d2y over dx squared. I should be integrating d2y over dx squared, so that here I should know that this is going to be the integral of d2y and the integral of 6x dx squared. So if I integrate this, I shall be having here dy, and this then shall be equal to 6 x square, x to the power 1 plus 1 gives me a square, and I should be dividing this by 2 and adding a constant. Let's say this constant is an a here. So we know whenever we integrate, we have to add the constant, which is a in this case. And then because it was a dx square, I should say that dx square when integrated shall give me a dx. So with that, I can say it's my dy by dx, which then shall be equal to a 3x square and a plus a. So we already know the condition that our first differential dy by dx equals a 0 when x equals a minus 1, meaning to get this value of a, I can just substitute the first differential here with 0, x with negative 1, and get the value of a. So 0 is equals to 3 times negative 1 the whole square and a plus a. Negative 1 the whole square gives me a 1, or I can say it's 0, which is equals to 3 plus a, or I can say it's my a, which is equals to negative 3. Meaning here I can have my first differential equation dy by dx, which then shall be equal to a 3x square minus a 3 here. After that, because I need to have the equation of the curve, so to get that, I should be integrating my dy by dx. So if I integrate my dy by dx, I got my dy by dx, I calculated my dy by dx, and this was equal to 3x square minus 3. So this is 3x square minus 3, or I can say it's dy, which is equals to 3x square minus 3 dx. Integrating it, integral of dy is a y, and here I should say it's 3x to the power 2 plus 1, giving me a 3, and then I should divide this by 3 also, and with this 3 I should be adding an x, and also I should be adding the constant. Let's call this constant a c now. So with that, this is going to be our curve equation, but I need to have the value of the c also. And for that, they have already given us the hint that the point 3 negative 2, it lies on the curve. This 3 negative 2, it lies on the curve. Therefore, in this equation, I can say that it's the point A with coordinates 3 and negative 2. They are present on the curve. So substituting the values, I should say it's negative 2, which is equals to 3 cube minus 3 times 3, and then a plus c. So from here, I should be able to get the value of c. 3 cube is a 27 minus 3 into 3. That gives me a 9 and a plus c. Or it's a negative 2, which then shall be equal to an 18 plus c, or I can say it's the c value, which is negative 2, negative 18, giving me a negative 20. So this is the c value that I have here. And from here, I should be able to get my equation of the curve. And the equation of the curve here is going to be y, which is equals to x cubed minus 3x and a minus 20. So this then shall be the equation of the curve and the answer to this question. Question 4. The gradient of a curve is given by dy by dx, which is equals to ax plus b. So given that the curve passes through the 3 points 0, 0, 1, 1, negative 2, 16, we need to have the equation of the curve. So again, the thing is to find the equation of the curve, and they have given us the first differential or the gradient equation dy by dx, which is equals to ax plus b. And over here, we already see that there are two unknowns a and b. So to find the two unknowns a and b, I should be first solving it with respect to 0, 0, 1, 1, negative 2, 16, and then finding out the equation of the curve. So let's start working on it. So it's dy by dx, which is equals to ax plus b, and there is no information about the gradient. and there are just 3 points given for this curve. Therefore, I should be integrating this equation dy integral here for ax plus b and dx. So if I integrate the equation, this gradient equation, then it's y, which is equals to ax squared divided by 2. And then to this b, I should be adding a constant. And then obviously I should be having, with this b, I should be having an x. And then I should be adding the constant, which is a c here. So now I can say y is in terms of x, but there are three unknowns a, b, and c. For that, I will first be using the first given point, which is 0 and 0. So if I substitute that as 0, my y is a 0, x substituted as a 0, obviously I can see that a and b, they are getting eliminated. And from here, I can see that my c value is a 0 then, which leaves me with the equation that is y, which is equals to ax squared divided by 2 plus bx. So my equation has reduced to ax squared divided by 2 plus bx. So c equals 0 also tells us that this is the curve which is actually passing through the origin, giving us the y-intercept, which is equal to 0. So a 0, 0, again I can see that it's the curve which is passing through the origin here. So using the second information, I have b, which is 1 and 1. So substituting that 1 and 1 in the equation, which is y is equals to ax squared divided by 2 plus b. If I substitute my y with a 1 and my x with a 1, then here I can see that I will be having my b in terms of a, which is going to be 1 minus a by 2 here. So here I have my b in terms of a, and for solving this a and b, I can be using the third equation. So the third equation, now let's call that point a c, which is given in the question as negative 2 and 16. So negative 2 and 16, again this point, they lie on the curve, therefore I can substitute this negative 2 and 16 in the y equation, which was a by 2x squared and a plus bx. So y substituted as 16, it's a by 2 and x is given as a negative 2 the whole square. I can substitute b also as a 1 minus a by 2, and then I have this a, which is a negative 2 here, this x, which is a negative 2 here. So I can see that now the entire equation is in terms of a, meaning I can very easily get the value of a here. So let's solve it further. It's 16, which then shall be equal to negative 2 the whole square. That gives me a 4a divided by 2. And here I shall be multiplying this positive with the negative 2, so that here I can say it's a negative 2, and then here it's taking LCM, this becomes 2 minus a divided by 2 here. This 2 gets solved, this 4 and 2, this also gets solved, so that now I can see I'm left with a 16, which is equals to 2a minus 2 plus a, or it's a 16 plus 2, which is equals to 3a, or I can see it's an 18, which is equals to 3a, or the a value, which comes out to be 18 divided by 3, which is actually a 6. So here I am able to get the value of a, which comes out to be a 6. And then from here, I should be getting the value of b. b is 1 minus a by 2. b from here, it's 1 minus a by 2. I can substitute this a as 6 over here, and solving that, it was b, which was equal to 1 minus a by 2. We got a as a 6. We got a as a 6, so I shall be substituting this a as a 6, so that this becomes 6 divided by 2, or I can say it's b, which is equals to 1 minus 3, or I can say that the b value here is a negative 2. So this is how I shall be getting the value of b, which equals a negative 2. And after that, I will be getting the equation of the curve. We got the equation of the curve from here as y equals ax squared plus bx, ax squared divided by 2 plus bx. So simply I'm just going to substitute in this equation a as a 6x squared divided by 2 and then b as a negative 2x, or I can say that the equation of the curve is 3x squared and a negative 2x, and this is how the equation then gets solved. So this is how simple it is to get the curve equation when the gradient equation or the second derivative equation is given to us. And then we know how to integrate equations and what are the basics of integrating an equation. Again, to recap, I should say that when we are integrating an equation, we have to add the constant, and to get that constant, which is c, which was c in this case, we were substituting the given points on the curve so that we can get the value of c, and then substituting that we shall be able to have the curve equation. So this is all about integration, the basics of integration, and I'll be meeting you in the next video for the next integration topic. So till then, take care and bye bye.